Hello everyone. In this video, this is the problem that we will solve. A fixed supported beam 12 meters long has a concentrated load of 1,200 newtons at the free end. Determine the shear, moment, and slope at support. Use EI is equal to constant. Okay, solution. Now you might be wondering, why are we solving shear, moment, and slope for our steel subject? Now in our module 6, I did not put it there yet, the problems involving the topics that will be under steel for module 6, but instead I'll put it for module 7. Now why we have to go through here first is this shear, moment, and slope at support are prerequisite values that we need to solve first before we can apply the design formulas in steel. That's why we'll have our review regarding problems solving for the shear, moment, and support. Now, first thing is we have no figure given. Instead, it made mention of a fixed supported beam. So from the statement, a fixed supported beam, it means that we have a beam, one end is fixed supported. Next, it has a concentrated load of 1,200 at the free end. So free end is the other end. So a concentrated load of 1,200 Newton. Now the question is the shear, moment, and slope at support. Now normally what we would do in our previous subjects such as statics and other subjects, what we do is first we'll solve for the reaction. After solving for the reaction, we draw the shear and the moment diagram. And then later on, we use different strategies in solving for the slope and deflection, such as double integration, moment area theorem, and other formulas to solve the slope and deflection at any point within our beam. Now, what I want you to do is to help you save time, which will be very important, especially when you graduate someday and take your board exam. Time is important. You need to learn the shortcut formulas for solving moment, shear, slope, and deflection for different or for common beam setups, such as a fixed supported beam. Now, this is a common beam setup. To solve for the shear at support for a concentrated load of a fixed beam and the concentrated load is located at the free end, the shear is simply equal to the load, which is 1,200 Newton. Okay. Next, moment at the support. This is support. For the moment at the support, that is simply the load times the length. Okay. This, of course, this formula is only applicable to a fixed supported beam and a concentrated load located at the end. So this is now 1,200 times 12. So the moment at the support is 112 times 12, 14400. So this is 14400 Newton meter. And okay. And finally, we have the slope. The slope at the support. The slope at the support, we need to remember that if this is a fixed support, then it cannot have a value of slope. So the slope is always 0 at a fixed support. So the slope is 0. So we have now these three answers. So I repeat, search it. Search, or even if you can check, I believe you can check the PDF which I provided to you in the previous module for the subject of, if you have your PDF in dynamics or mechanics, I believe there's formulas there, or if not, you can try and search the internet to search for the shortcut formulas for solving common beam setups to solve for the shear, moment, slope, and deflection for different common beam setups. The common beam setups are fixed supported. We also have the simply supported. We also have the prop end beam and the double fixed end, meaning both ends are fixed. Just for example, we have here a double fixed ended beam, and it is loaded with a uniform load. If we want to solve the moment at the support, the formula for that is WL squared over 12. That is how to solve for the moment. Because if you notice, fixed and fixed, this setup is indeterminate. So it might take you a very long time to solve for the moment of support if you go with the long method. So the formula for that is WL squared over 12, the moment for the support for a double fixed end with a uniform load. So I repeat, research the internet or any references, the shortcut formulas to solve the shear, moment, slope, and deflection for common beam setups. That is all.